Hey everyone, welcome back to my YouTube channel. Our solar system, a cosmic ballet of planets orbiting our sun, often appears to us as a perfectly ordered, immutable system. 8 planets, each in its well-defined orbit, from Mercury's scorching closeness to Neptune's icy frontier. But what if this picture, so familiar and reassuring, is incomplete? What if, hidden within the gravitational echoes and scattered debris, lie the ghosts of worlds that once were, or perhaps, worlds that should have been? This is the story of our solar system's missing planets, a tale of cosmic evolution, violent upheaval, and the enduring mysteries that challenge our understanding of our own backyard. For centuries, astronomers meticulously mapped the heavens, charting the paths of the known planets. Yet, even in this seemingly perfect clockwork, an anomaly persisted. Between the fiery red expanse of Mars and the colossal grandeur of Jupiter, there existed a vast, inexplicable gap. It was a space that, according to a curious mathematical pattern, should have housed a planet. This pattern, known as the Titius-Bode law, was a simple, empirical rule that predicted the approximate distances of planets from the Sun. It worked remarkably well for the known planets, from Mercury out to Saturn, and it pointed to a missing world right in that gaping void. This wasn't just a minor discrepancy. It was a profound missing piece in the cosmic puzzle, a silence in the celestial symphony that begged for an explanation. Was there a planet there that had vanished? Or had something prevented a world from ever forming? This cosmic enigma, nestled in the heart of our solar system, was the first tantalizing hint that our planetary neighborhood held a deeper, more turbulent history than we had ever imagined. Act 2. The first clues the story of the solar system's missing worlds truly begins in the late 18th century, with the growing influence of the Titius-Bode law. This mathematical sequence, first published by Johann Daniel Titius in 1766 and popularized by Johann Elert Bode in 1772, proposed a surprisingly accurate formula for the distances of the planets from the Sun. It predicted a planet at 0.4 plus 0.3 times 2 to the power of n, where n was a sequence of numbers. For Earth, n was 2. For Mars, n was 3. For the next step, n equal to 4, the law predicted a planet at approximately 2.8 astronomical units from the Sun, a region where no planet was known to exist. This mathematical void ignited a scientific quest. Driven by the Titius-Bode prediction, a group of astronomers, humorously dubbed the Celestial Police, began a systematic search for this elusive ninth planet. Their efforts culminated on the very first night of the 19th century. On January 1, 1801, Giuseppe Piazzi, an Italian astronomer working at the Palermo Astronomical Observatory, stumbled upon a faint, star-like object moving slowly across the constellation Taurus. Piazzi, initially believing it to be a comet, meticulously tracked its movement. After several weeks, his observations were sent to other astronomers, including the brilliant mathematician Carl Friedrich Gauss, who calculated its orbit. The object was indeed orbiting the Sun at approximately 2.8 astronomical units, precisely where the Titius-Bode law had predicted a planet should be. This new discovery was named Ceres, after the Roman goddess of agriculture and patroness of Sicily. For a brief period, Ceres was hailed as the missing planet, fulfilling the Titius-Bode prophecy. However, the celebrations were short-lived. Just a year later, in 1802, Heinrich Albers discovered another object in a similar orbit, which he named Pallas. Then came Juno in 1804 and Vesta in 1807. It quickly became clear that these objects were far too small to be considered full-fledged planets. They were merely fragments, thousands of them, populating the vast space between Mars and Jupiter. This region, once thought to be home to a single missing world, was instead a chaotic swarm of rocky bodies, which we now call the asteroid belt. The initial theory that emerged to explain this collection of small bodies was that they were the remnants of a planet that had somehow shattered. Perhaps it was a cosmic collision, or some internal cataclysm that ripped a world apart. This idea of a shattered planet captured the public imagination and offered a dramatic explanation for the Titius-Bode anomaly. However, as our understanding of planetary formation evolved, this dramatic narrative began to unravel. The combined mass of all the asteroids in the belt, even today, is less than that of our moon, far too little to account for a full-sized planet. The shattered planet hypothesis, while compelling, gave way to a more nuanced and complex understanding of how our solar system truly formed. The missing planet wasn't shattered. It was a planet that, for reasons far more profound, never had the chance to fully coalesce. Act 3. The modern investigation * modern astronomy, armed with sophisticated telescopes and advanced computational models, has painted a far more intricate picture of the asteroid belt and the forces that shaped it. We now understand that the asteroid belt is not the remnant of a shattered planet, but rather a region where a planet failed to form. The primary culprit in this cosmic tale of non-formation is none other than Jupiter, the king of planets. Jupiter's immense gravitational influence, even in its early stages of formation, stirred up the material in the region between Mars and itself. Instead of allowing dust and rock to gradually accrete into a larger body, Jupiter's gravity constantly perturbed these nascent planetesimals, causing them to collide at high velocities. These violent impacts led to fragmentation rather than growth, preventing any single body from gathering enough mass to become a planet. The asteroid belt, therefore, is a testament to Jupiter's dominant role in sculpting the inner solar system. But the story of missing worlds doesn't end with the asteroid belt. Our current understanding of solar system formation suggests a far more dynamic and violent early history than previously imagined.